All right, let's talk about energy types. There's not really that many energy types, and honestly, today's notes are not very complicated. Things are gonna start getting complicated next class and the class after. So I think these first 2 days weren't too bad. The network was a little bit weird, but once you got into the rhythm of it, I think you guys got it. You just calculate work a few times and then you add them all up. With energy types, we have three main types of energy. This is our main type of energy, kinetic energy. We're going to abbreviate it as K. And it's the energy of moving objects, but it also has a definition. Our definition, like we talked about with work, our definition is an equation. In this case, our definition of kinetic energy is also an equation. It's 1/2 mv squared. That's it. But obviously, our m is mass here, our v is velocity here. Therefore, let's talk about a mass moving. So if an object is moving, it has velocity. If v was 0, so if we weren't moving, our kinetic energy would be 0, right? Mass is always positive, and velocity can be negative, right? However, if we have a velocity squared, this number always has to be positive. Therefore, kinetic energy is also always a positive number. Okay. Not all energy is always positive. Energy can be negative, but kinetic energy will always be positive, or 0. It can be 0 as well. Potential energy is stored energy. Okay. So we have a couple different types of potential energy. So don't always think about gravity when we talk about potential. But when I say potential energy, you should just think stored energy, okay? It means that you are in a position or a state of being where work can be done to you. You're in a position where you have the potential to do something. That's why we call it potential energy. There's the potential that work is going to be done. We have a couple types there's many types actually. There's chemical and there's other things, but we're only going to talk about gravitational and spring. Okay. I think these slides are out of order actually. So here's the kinetic energy example. So let's go ahead and do this real quick in case you want to calculate it and get practice calculating kinetic energy. 1/2 mass v squared. So in this case, our mass is 80 because we have an 80 kilogram man. And it's running at 5 meters per second. 5 times 5 times 80 times 0.5. Multiply all these things together, you should get 1,000. Make sure you get that number. You can do it in your calculator. Just do 1/2 times 80 times 5 squared. You should get this answer. Okay, so the first type of potential energy we're going to talk about is gravitational potential energy. Okay, so this is stored energy because of where an object is placed. It's the potential of an object, if an object is high up, gravity has the potential to bring it down, right? The higher you are up, if you're on some sort of cliff, gravity has the potential to pull you down off that cliff to your doom, okay? And so be careful with gravitational potential energy in your life, and it has this equation here, UG equals mgh. Mass times g, which is our 9.8. Mass, this is the same g we always know, g equals 9.8. And our height is whatever our height is. So, if you have a height of a building, you just plug that in there. Make sure your g is not negative in this case. For the most part, we're going to have positive potential energy. We can have negative if our height is negative, so if we're below a surface, but if we're on the surface or above, then our height is positive, and g is always going to be positive. Okay, so for the most part, we're going to deal with positive potential energies, but it can be negative in this case. So if a penguin plans to dive off a cliff into the water below, the cliff is 32 meters high, how much potential energy does the penguin have? It's as simple as plugging it in, mass times 9.8 times the height. So just mgh. And just throw it into a calculator. Don't try to do this in your head. Just throw it in. And then we have this much potential energy, which means this much energy is stored in the penguin and has the potential to become some sort of other energy, depending on what happens. We also have spring potential energy. If an object is attached to a spring and is compressed or stretched, then the spring has the potential to do work to that object, right? think about it. If you put an object on a spring and you compress or stretch it, it's going to try to push back. And if it pushes back, then it's going to give energy to that object. It's going to speed it up or slow it down. It has the potential to do work due to the spring. This equation looks quite similar to the kinetic energy equation. That's fine. It should. It comes from similar physics. So our potential spring energy is equal to 1/2 k x squared, where k is our spring constant, the same one that we would use in forces, whatever. So it's just your spring constant. And then x is same thing that when we use springs and forces. This is the displacement of the spring. So it's how much the spring is compressed or stretched. Okay. Notice k, our spring constants are always positive. And again, anything squared always has to be positive unless we deal with complex numbers, which we don't in here. So in this case, spring potential energy will also always be positive or 0. So if there's no stretch or compression, then it's just 0. Okay, so the only thing that can really be negative for us will be gravitational potential energy, and that's going to be, it'll happen, but it'll only happen very rarely. Okay, so let's say a spring with constant 1200 Newton meters is stretched 0.25 meters. How much energy is stored in the spring? And so it's as simple as U of S is equal to 12. My bad. Let's go ahead and just write the equation 1/2 kx squared. So that's equal to 1/2 k, which is 1200 here. Our x is 0.25 squared. So let's go ahead and do that. 1200 times 0.25 squared times 0.5. I got 37.5 joules. And that's really it. It's not a hard day today. We're just giving some definitions for you, and I'm going to give you practice calculations. You need to be fluent in these calculations, okay? These need to be trivial for you by the end of today. Just being able to calculate k given an mv, and you need to be able to go backwards. And so these homework problems, you're going to be finding m given k and v. You're going to be finding v given an m and k, okay? You're going to be solving for everything in each one of these, okay? So these need to be pretty simple for you. The first, I think, 12 problems on the homework are going to be just simple calculations, and then I'm going to throw in some slightly more complex problems, but I'm going to try to make sure that I walk you through them, because really those problems are going to be what we're learning to do next class. And so they still shouldn't be too hard. I'm not doing anything crazy. All right. Have a good day.